Hello, scholars, and welcome to Math with Mr. A. So, the way I need you to do this lesson moving forward is you want to solve everything on your own first. Then you want to get answer key from parents and check answers. The video is you can watch. You can watch the video and take notes for problems that are incorrect. All right, so let's get started. Decide whether each inequality statement is true or false. As you know, like these are inequalities, right? Right here, these are what you call inequalities. Inequalities mean greater than, less than, right? So inequalities mean greater than or less than, and the open part of the inequality shows the greater number. So this inequality says -5 is greater than 2. So let's just see that in visual context, right? So this is 0, this is 1, this is 2. This is -5. We know that negatives are smaller than positive. So this is saying it when comparing this number and this number, it's saying -5 is bigger. Well, as we know, 1 is bigger than 2, so this is incorrect, right? -5 is smaller, right? So the right answer would be -5 is smaller than 2, but this is incorrect. Says 3 is bigger than -8. Let's see. So this is 0, -1, -2, -3, -4. 3 is over here, -8 is over here. As we know, positives are bigger than negatives, and the bigger number, or like the shark, bites the bigger number, so that is correct. Because 3 is larger than -8. This says -12 is larger than -15. Well, let's see. So this is 0. This is -5. This is -10, -11, -12. In negatives, the bigger number is closer to 0 or greater. The greater number is closer to 0. Okay, so the bigger is the closest to 0, right? So we have, oh, and this is -15. So we have -15 here, -12. Because -12 is closer to 0 and 15 is further from 0, -12 is bigger than -15. Um, so let's say this is 0, -10, -11, -11.5, -12, -12.5, -13. So -12.5 is between -12 and -13. -12 is there. This is saying negative 12.5 is greater than negative 12. Well, we know the greater number is the closest to 0. And since negative 12 is closer to 0, negative 12 is actually greater than negative 12.5. So this is incorrect. Okay, so here is a true statement. Negative 8.7 is less than negative 8.4. Let all the statements that are equivalent to negative 8.7 being less than negative 8.4. Well, first, let's just see if that makes sense, right? So here, all right, we have negative 6, negative 7, negative 8, negative 8.1, 2, 3, 4, and negative 9. So negative 8.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9. Negative 8.1, see that? Negative 8.1 through negative 8.9. Negative 8.7 is here. And negative 8.4 is here. Since negative 8.4 is closest to like 0, right? That makes it greater than negative 8.7, right? Now we got to figure out why. So negative 8.7 is further to the right on the number line. So this is the right, this is the left. Is negative 8.7 further to the right than 8.4? No. Negative 8.7 is further to the left of number 7? Yes. Negative 8.7 is less than 8.4. Well, yes, because it's furthest to the left and negative 8.4 is closer to 0. So that makes negative 8.4 bigger than negative 8.7. Negative 8.7 is greater than negative 8.4. Negative 8.4 is not greater, it is less than. So that is incorrect. Negative 8.4 is less than 8.7. Well, negative 8.4 is greater than 8.7, so that is incorrect. Negative 8.4 is greater than 8.7. Yes, that is correct. Do you see how like visual representation, and I know that I need to answer more because it says select all. Plot each of the following numbers on the number line. Label each point with its value. So 0.4. So when you're dealing with numbers that are not whole numbers, like decimals tell you you need to, there will be like a split between the whole. So what do I mean by that? Let's take 0.4 for example. 0.4 is between 0 and 1, right? But to get a clear, like really, really good thing, you have to split it, right? So that's 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. You see how I split it in tenths? This is a tenth, so it makes sense to split into tenths. And 0.4 would be, this is 1 tenth, 2 tenth, 3 tenth, 4 tenths. So 0.4 is right here. Negative 1.5. Now this is a negative, so it's going to be on the negative side. And negative 1.5 is between negative 1 and negative 2. But this 5 tenths tell us I need to split it. And 5 tenths is usually the middle, right? So this is, so negative 1.5 is there. This is -1 7/10. That's written as a fraction. You want to write our fractions like decimals, right? So 1 and 7/10, because the 7 ends in the tenths place, but it's negative. So it's between -1 and -2, but it's 7/10. It's 1, 5/10, 6/10, 7/10. -1 and 7/10. You see that? How it's right here? And 11/10. Well, 11/10 is a mixed number. 11/10 is equivalent to 1/110, or 1.1. And 1.1 is between 1 and up, negative. This is why you want to list your negatives and your positives. 1.1 is right here. The next one. The table shows 5 states and the lowest point in each state. Put the states in order by their lowest elevation from least to greatest. Okay. So when you're thinking of least to greatest, of course, you know the least is the furthest from zero. The greatest is the closest to zero, and the furthest right from zero. So if we had a number line, let's say we create a number line, we want to put these numbers on the line. Let's say this is 0, right? -8 would be close to 0, but on the negative side, right? So we did that. -282 would be further, um, +2,000, well, 2,842. Yeah, 3,099 or 3,300. Well, since in the hundreds place, well, the tens place, the tens place is a 3, but the tens place here is a 0. So the next number would be 3,000. Yeah, the biggest number would be 3,350. So I did it from least to greatest. We know the smallest number is the furthest to the left. And we know the biggest number is the furthest to the right. So if I was to write this in order, I would say -282 for small list, -8 for small, then 2,842 big, 3,000 bigger, and 3,350 at its biggest. So this is from least to greatest. All right, let's go to the next one. Um, each lap around the track is 4,000 meters. How many meters would they run if it's 2 laps? Um, So let's say um we could do it multiple ways, but let's create an equation around this. So 400 meters is a lap, but each lap it would is a co is a coefficient. 400 laps, which means when laps is two, it's 800 meters. When laps is five, it's 2,000 meters. And when laps is X, it's 400X, as in like L or X. If Noah ran 14 laps, how many meters did he run? Well, you could substitute 14 for X. Uh, and it's 14 times 4 hundreds. So that's 16. So that's 7,600 meters. If Noah ran 7,060 meters, how many laps did he run? So 7,600 equals 400x, meaning how many laps? Oh, that's simple. You could just divide. You could isolate the variable, divide by 400 on both sides. And since these cancel out, right, it's just like 76 divided by 4. 4 goes in. Oh, he ran 19 laps. You could do it the algebraic way, or of course, you could do it a table. Meters, laps, we know 400 meters is one lap, um, which means to get from meters to laps, you divide by 400. And then to get from lap to meters, you multiply by 400. So 2 laps is times 2, which is 800. 5 laps is times 5, which is 2,000 meters. And we ran 7,600 meters. We know to get from here to here, you divide by 400, and that is 19. So that is the ratio table way, and this is the algebraic way. A stadium can seat 1,600 people at full capacity. Cool. There are 13,920 people in the stadium. What percentage of the capacity is filled? Um, so fractions, a fraction is like a part of a total, right? If the total is 16,000 and the part is 13,920, to find the percentage, you just divide 13,920 by 1,600. Oh, sorry, 13,920 divided by 16,000. That was 87%. So it's 87% filled. What percentage of the capacity is not filled? Well, if 87% is filled and 87% is partially filled and 100% is completely filled. 13% is not filled, right? So, because I just subtracted like 100% minus 87 to figure out how much is left. All right, that's it for today.